this problem, we want to find all relative extreme of the function and use second derivative test when applicable. So f of x is equal x to 1/3 minus 4. Now our second derivative test. It's not going to work, but let's try it and just show it. First step, find the first derivative. So f prime of x, take your power, put it out in front, lower it by 1. The negative 4 drops away. That gives us 1/3 x to the negative 2/3. Now, for purposes of the second derivative, we're going to continue from this point right here. But to find our critical values, which is going to be in step 2, we need to take that x to negative 2/3 down to the denominator. So we'll have 1 over 3x to the positive 2/3. Remember, when you take anything opposite in a fraction, the sign of the exponent changes. Step 2, set equal to 0 and solve critical values. Well, remember, when you have a fraction, you set your top part equal to 0 and your bottom part equal to 0. So I'll set 3x to the 2/3 equal to 0. 1, we don't need to worry about setting equal to 0 because there's nothing there. Now, whenever you have an x to a power and a number out in front equal to 0, this just always becomes x equals 0. Because if you divide both sides by 3 to get rid of this, 0 divided by 3 is 0. If you take both sides to a power, no matter what it is, to get rid of the 2/3, 0 to any power is 0. So it always works out that way. Now, this is our critical value. Step 3, find the second derivative. Okay, so we're continuing from here. F double prime, 1/3 stays out in front. Take your power, put it out in front. Lower your power by 1. So we got negative 2/3 minus 1. Now 1/3 times negative 2/3 gives us negative 2/9 x, and that gives us negative 5/3. Yeah, negative 5/3. Which would give us negative 2 over 9x to the 5/3. Now it says plug in your critical values from step 2 into second derivative. Critical value is 0. If I put 0 in here, though, we get 0 to the 5/3 power, which is 0, times 9, which is 0, so we get a 0 in the denominator. F double prime is undefined, so it fails. You cannot use the second derivative test. Now there's 2 times when it fails. That's the first one, and the other one is this right here, where your f double prime of your critical value is equal to 0. So we have to use the first derivative test. So let's start over. This helps point out why I don't like second derivative test. Doesn't work all the time. Okay, so we got x to the 1/3 minus 4. So our first step is to find our derivative. Take your power, put it out in front, lower it by 1. The negative 4 drops away, which gives us 1/3 x to the negative 2/3, which would give us 1 over 3x to the positive 2/3. Well, we need to find our critical values. So set our top part equal to 0, set our bottom part equal to 0. Don't need to worry about top. So we got 3x to the 2/3 equal to 0, which we've already said that gives us x equals 0. Now 3. We want to build our table of intervals based upon our critical value. Clear over here is negative infinity, clear over here is positive infinity. We want to choose test cases. Something between negative infinity and 0, like negative 1, and something between 0 and positive infinity, like 1. Now we want to plug those into our derivative, which is right here. Now it's probably just as easy to plug that in a calculator. And the key is, if you got more than a single number, a single variable on the top or bottom, you have to put parentheses around it. So I'll plug this in, I'll put parentheses around the bottom part. If you got more than a single number or a single variable in your exponent, you have to put parentheses around it. So I'll put parentheses in right there. Now, if you're pretty good with fractional powers, rational exponents, you can do this in your head, and it's very easy. Like this here, if I would have put -1 in here, all that would give me a positive, which means it's increasing. If I put 1 in there, it's also positive, which means it's increasing. Okay, but let's show it on a calculator. I press y equals, y equals, clear, and I got 1 divided by, beginning parentheses around the bottom part, 3, then x to 2/3. So x caret, and then we have to put parentheses around the exponent. So 2/3. Closing parentheses on the exponent, closing parentheses on denominator. Now you want to go in your table setup, so do second window. You want your independent to say ask. If it doesn't say ask, down arrow to that line, right arrow, put your flashing cursor on the ask, and press enter 1 time. Then you go to second graph, table, and if I put in my 2 critical values, -1 and 1, -1 enter, 1 enter. You see they both give me a positive, which means these are both increasing. Now, our specific instructions here said find all relative extrema. Relative extrema only exist when it changes from increasing, decreasing, or vice versa. So for this problem, there is no relative extrema, no relative mins, no relative maxes.